Hi all, welcome to Soumya Tech Talks. Today, before going to C programming language, so we will discuss some basic things about memory. So we will discuss what are the different types of memories in the system and how are the unsigned decimal numbers stored in a memory and how they are retrieved back and displayed as decimal numbers, and also signed decimal numbers, how they will be stored and how they will be retrieved again from the memory. And also if you have a decimal numbers with fractions, how they will be stored. And also we will discuss how that already stored decimal numbers having fractions so will be retrieved from the memory. Okay, so normally in any system the memory, if you see, it is just uh, zeros and ones. So each cell, memory cell, is a zero, zeros or ones, right? Like this. So yeah. So in memory cell, in electronic devices, the memory cell, each cell is a one bit. So each bit, it may be zero or one. It will be stored like it has a different cells based on the size of the memory, and each cell represent either one or zero. So this is how any type of memory, either it is a flash memory, RAM, or SD card, whatever it is there, it will be in this format only. Okay. So normally there are two in any electronic device. There are two type of memory. One is primary, which is used to store current running programs and the data of the current running programs and operating system, kernel and operating system which is currently running. So this is called RAM, random access memory, and it is volatile, means whenever you turn off the system, it will be, the memory inside it will be lost, and it is very less in size compared to the any secondary memory, but it is very fast. So the writing and reading from that memory is very fast. So if you see the secondary memory, which is called your hard drive, like either it can be solid state disk, flash memory, or HDD hard disk. Okay, so it is non-volatile, means whatever stored, it will be available entire lifetime of the device. So it will be very huge, like you can have a 1 terabyte, 500 GB, like that. So it is very slow. So that it only store the data, but systems never run any programs using this memory. So whatever program stored here will be first taken to primary memory, and then from there it will run the program. Okay. For example, if you have a hard disk, okay, this is what happens. So you start a program and the CPU will ask hard disk to load the program into RAM, and then from RAM it will execute. Okay. So for example, if you have a decimal numbers like positive or signed means they don't have sign, so by default they are positive. So how it will be stored in the memory? So as we know, anything in the electronic devices, it should be converted into binary form, means ones or zeros. So let's say you have a 128, so it will be converted using the binary division. Like you will divide first 128 with 2, so you will have a 64, and your result is 64, and you have a 0. Okay, so now that 0, whatever is there, it will be taken, and the 64 will be again divided by 2. Okay, and the result will be 32 and 0. So 0, whatever remaining remainder will be taken, and 32 again will be divided by 0, like this 16, until it is uh, 1 less than 2, it will be division like this. So here it is 1 which is less than 2, so it will stop and take all the reminders. Okay, like first reminder, second remainder, all it will take. So this is your binary representation of your 128. So 128 will be stored like this. Okay. So 128 will be stored like this in this representation. So here it is, we will call MSB and LSB. So LSB is the least significant bit. We will discuss these things in later sections, more details. But right now the right side, whatever is there, it called least significant bit, and left side is the most significant bit. So we will discuss about this in the later lectures. So this is how. So let's say you have a now it is let's say you have in memory something is stored. Okay, so how it will be retrieved again? So you have a least significant bit and most significant bit. So least significant bit is, it will start from 2 power of 0. This value of this uh, index is 2 power 0. So here it is 2 power 0, 2 power of 1. So left side to your right side to left side, it will increase. The power of 2 will be increased. So here this bit, it is 2 power of 0, 2 power of 1, 2 square, 2 cube, 2 power of 4. Like this, you have any numbers. Let's say it can go up to 2 power of 64 if it is 64 bit is supported. Okay. So each one is 1 bit. So how this will be converted to a decimal again? So first what it will do? So 2 power of 0 into the value here is 0. So 2 power of 0 into 0. So here I am multiplying 2 power of 0 and 0. So this will be 0. So next 2 power of 1 into 0 means first I will take 2 power of 1 and the value the data stored in the cell is 0. So 2 power of 1 into 0, it is 0. So again like this, 2 square into 0. So 2 square and the value stored in this cell is 0. So it is 0. So like this, you can, it will convert each cell value, it will calculate like this. Okay. So here you can see 2 power of 7, the cell value is 1 bit, bit 1. So 2 power of 7 into 1. So 2 power of 7 is your 2 power of 7 is 128 into 1, 128. Now it will add all this. Okay. And then you will get the final result 128. So this is how a binary value stored in a memory will be converted to decimal back again. Okay. Now if you have that is whatever we discussed earlier is a positive number, means it either don't have any sign or it has a sign. It don't have sign or positive sign. So now if you have a negative numbers, so negative numbers will be stored in the 2's complement, means 2's complement is a notation. So any negative number, first it will be converted into 2's complement binary number, and then it will be stored in the memory. So 2's complement will be calculated. First it has to convert the into 1's complement and then add 1, you will get the 2's complement. Let's see with one example. Let's say you have minus 128. Okay, its binary value is this one. Okay, now 1's complement is you invert each bit. Like if you see 1, you invert it to 0. If you see 0, it is means inversion, like 1 bit 1 become bit 0, 0 become 1, like that you invert all the bits. Okay, that is called 1's complement. So after you have 1's complement, you will add 1. Okay, binary 1. Okay, means so this addition and everything, the binary addition, subtraction, this one we will discuss in later sections. But right now, you see, if you add, the result will be like this, add 1. So we will discuss this about this more in the further lectures. Okay. So if you add 1, you will get this result. So this will be stored in the memory. So again, there is a least significant bit, most significant bits. Okay. So this bit will indicate the sign. Okay. So now if you have a negative numbers in the stored in the memory in binary format, how it will be retrieved back? Let's say you have stored here, so there is a most significant bit, least significant bit. So actually this value is minus 127 as we discussed in earlier slide. So this is stored in memory. Now let's see how it will be converted back to decimal. So first it will see the most significant bit. So if it is 1 means that is a negative number. If it is 0 means it is positive number. So in our case it is 1, so it will be negative numbers. Now it will convert this to ones complement. So as we discussed, ones complement is invert all the bits. If it is 1 to 0, 0 to 1 like this. And then again add 1. So whatever number comes, so that one you will convert, it came this one. Now this convert this to decimal number like earlier formula like 2 power of 0, 2 power of 1, like this you convert it. Now we got sign is minus negative and value is 127. So ultimately it is minus 127. Okay. So now if you have a floating point numbers, for example, you have a floating point number 127.87. So it has two components. Okay, whole number is 127 and fractional part is 87. So this is whole number 127. This is fractional part. So both should be stored in memory, right? So how it will be done? So first, this is scientific notation. Whatever we are discussing, this is the scientific notation. So right now, uh, so in scientific notation, so first you will convert the whole number part into binary using the previous slide we discussed, right? In that way, using that formula, you will convert. So again, fractional part you have to convert into binary. It is done by multiplying the fractional part by 2 repeatedly, and we will take the integer part. Like first we will multiply 0.87 to 2. It comes 1.74. So we will take the integer part, means it is 1, and fractional part is 0.74. So now what we will do? We will take the fractional part and again multiply by 2. It is 1.48. So we will take integer part, okay, and fractional part. So again this fractional part we will multiply 0.48 into 2, 0.96. So you will get 0 and fraction 96. Like this we will do how much accuracy we want. Like, so the fraction may be accuracy, right? You have accuracy up to uh, 3 digits after the decimal point, 5 digits, like that. Whatever accuracy you want, you have to multiply, keep on multiplying like this. So once it comes, all integer parts like here 1, 1, 0, 1, 1 like this, how many are there, we will take that. Okay, now finally see here, this one we will take dot this one. So your result of scientific notation for 127.87 is this one. Okay. So right now in computers, we don't, it is earlier they are storing like this, but in modern computers, so this scientific notation is not, this result is not stored. So again, they will convert to another form. So we will discuss now. Okay, how in modern computers the floating point numbers are stored. So let's say you have any floating point numbers like 127.75 or negative with sign, so they will be stored in IEEE 754 floating point representation. We will discuss how to convert any decimal number with fraction to this format, this binary format. Okay. So there are two types of IEEE. You can have 32-bit and you can have 64-bit. So if you want more store larger numbers, you can have 64-bit IEEE 7554. If you want very limited range, you can have 32-bit. Okay. So IEEE 754, it has three fields. One is sign, which represent 1 bit only. Sign is 1 bit. Okay. So if it is 1, it is negative number. If it is 0, it is positive number. So exponent exponent is a component. Exponent will be for 32-bit floating point numbers, it is 8 bit. For 64-bit floating point number, it is 11 bits. So now we will have to calculate a bias. Okay, bias is 2 power of k minus 1 minus 1, where k is the number of bits. Like bias for 32-bit, so the number of bits is 8 bits. So 2 power of 8 minus 7 means 2 power of 7 minus 1 is 127. So for all any 32-bit floating point number, the bias is fixed 127. For 64-bit, the k is 11 because 11 bits. So if you use this formula for all 64-bit floating point numbers, it is bias is 1023. So after that, what we will do? Any given number, okay, we will take its nearest 2 power of n number. Let's say you have given a 17, right? So its nearest 2 power of n is, which should be less than this also. So nearest 2 power of 2 power of n number is 16, because 16 is 2 power of 4, right? So that is near to 17. So we will take that and we will find the n. N is the power of 2 in the nearest 2 power of 1. In case of 17, the nearest is 16. It means 2 power of 4. So the n is 2 power of 4. So n is 4. So exponent value is the binary form of your bias, means either 127 or 1023 plus the n you got. Okay, adding those two, you will get the exponent. So next is third part is mantissa. So mantissa, it is for 32-bit. It is for 32-bit number, it is 23 bits. For 64-bit, it is 52 bits. Okay. So first we will calculate the n, how we did here. Okay. So now we will convert the number into scientific notation. Okay. And then move the decimal point to n points left side. Okay. And take that left side, and we only take whatever binary number comes after the decimal point, and we will take that as a mantissa. So we'll discuss with an example. Okay, so let's say you have a 1234.565. It is a decimal number with fraction, right? So first what we will do, first 1234 we will convert to binary. So that is this 10011 something is there, right? So this is the binary representation of 1234. So we have a decimal point. So 565 we will convert using scientific notation. So we know, right? We will keep on multiplying with 2 and take the integral parts. So using this, you will convert to this one into the binary. Okay, all integral parts I have taken. So this is so now I have converted to scientific notation. So once I get the scientific notation, I will calculate sine, exponent, mantissa from this scientific notation. Sine will be, so the number we took is positive, so it is 0. So exponent will be, so as we see the 32-bit IEEE 754, the mantissa is always, the exponent is always 127. Sorry, bias is 127. So the nearest of 1234, the nearest 2 power of n is 1024, right? So 1024 is 2 power of 10. So this 10 is n. Okay, the exponent is bias 127 plus n 10. So our bias is 137. So the binary of one representation of 137 is this one. So we got the exponent. Now we have to calculate the mantissa. So for mantissa, we already know that n is 10 in our case. So and this is our binary scientific notation. This is our scientific notation. Okay. Now what we have to do? We have to move the decimal point with 10 positions right side. Okay, like this we have to move. Okay. So now this will come. So we will omit this whatever there before 1, before the decimal point, and we will take all the values after the decimal point. So our mantissa is this one, and it should be for 32-bit, it is 23 bits, right? If it is less than 23 bits, so you can add zeros in the right side to make it 23 bits. So here it is 20 bits only came, right? So till this one, I still need to add 3 more bits padding. So I will add 3 zeros so that it is 23-bit mantissa. So now in memory, it will be stored for 1234.565 in the memory, in the RAM, this is the value stored. Okay. So for all floating point numbers, so it will convert like this and store in the memory in the binary form. So now how it will be retrieved? Let's say you have a floating point number which is stored in the memory. Now you have to retrieve back to display to the user or something, right? So first it will take the most significant bit, that is sign. So it is 0, I mean sign is positive. If it is 1, it is negative. Next one is exponent, it is 8 bits. So here I am taking example as 32-bit floating point number. So mantissa, sorry, exponent is 8-bit. So the decimal is, exponent I will convert to decimal. It is 137. So the real exponent is exponent value minus bias, like 137. Always for 32 floating point number, bias is 127. So my exponent is in decimal number 10. This is decimal number. Okay. Now what I will do with mantissa? Mantissa is 23 bits. Okay. Now I will convert this mantissa to decimal. So how I will convert? Bit 0 I will take from right side, bit 0 into 2 power of 0, bit 1 into 2 power of minus 1, bit 2 into 2 power of minus 2, like this. Bit 2 3 into 2 power of minus, like this. I will add all this. So I will add, say here 0 is first bit, 0 into 2 power of 0 1, 0 into 1, 0 into 2 power of minus 1 is 1 by 2, right? It is 0.25. Again 2 square is 2 power of minus 2, means 1 by 2 square, it is 1 by 4. So 0 2.25, like this. I will add all this. So I will get the decimal mantissa as this one, 0.1015 something something. So this is my decimal mantissa. So now the formula for conversion is, so what is the formula? Minus 1 to the power of sign. So sign is always 0 or 1. Minus 1 to the power of sign into 1 plus mantissa. So whatever decimal mantissa you got, add 1 to it, into 2 power of exponent. Whatever exponent you got, like here we got 10, right? So this is the formula. So here 1, I have sign is 0. So 1 power of 0 is 1. Okay. So minus 1 power of 0 is anything, power of 0 is 1. So 1 into 1 plus my mantissa here, I will get this one, into 2 power of 10 is 1024. So I will get the value as 1 2 3 4 5 6 5. Okay. So as a programmer, if we know these internal details, so it will be very helpful to do more practical things and more advanced programming. And if you want to do more uh, complex algorithms, so this we should, every programmer should know these basics, right? So that's why I covered this topic before going to actual C programming course. Okay. Thank you all. Thanks for watching. So we will end here and we will see you in the next lecture. And please subscribe the channel and also share with your friends. So happy learning. Bye.